Now we are ready to talk about the basic wide area network WAN topology. Assume that we have 6 network devices with 3 different network addresses. Personal computers, laptops, tablets, network printers, network scanners, IP phones, servers, smartphones, switches, routers, modems and other connected devices can be connected from different LANs. And we know that all these connected devices have different type of NIC cards. These NIC cards can be embedded into motherboard of the device, or they can be plugged into the device externally with USB interfaces. All these NIC cards have different IP addresses related with their network addresses, but always have the same MAC addresses for connecting the network. As you know that router is a kind of gate controller and data routing device for each LANs. If the data packet that generated by your computer will be sent to the internet or any other different LANs, the router prepares this data packet and sent to the ISP service network. The data packet goes outside the local area network by using routing protocols. The data packet will be tagged with the source and destination network addresses, and the router chooses the right way to send these data packets. And please remember that routers with routing protocols act like GPS devices that route the data packets. Routing protocols mark the address of the next router on the data packet. When the packet arrives at the next router, the new address information is marked and data packet continues on its way in the wide area network. The router on which the destination network address is defined receives the packet from wide area network and forwards the packet to the target computer in the local area network. The data packet has now reached its target device. If the data packet comes from the internet as the response of any send data packet, the router receives this data packet and sends it to the relevant computer in LAN. Like IP addresses, subnet masks have also 32 bits. In the examples that we have done, the values of 24 bits are 1 and the values of 8 bits are 0. So we can also use /24 for short representation of the subnet masks. When we look at the first example of 210.168.40.16/24, we can easily understand that 210.168.40.16 is the IP address. /4 is a subnet mask which is 255.255.255.0. Now we can start to examine all the 6 IP addresses one by one. For device 1, IP address is 210.168.40.16/24 and the network address is 210.168.40.0. For device 2, IP address is 192.168.64.200/24 and network address is 192.168.64.0. For device 3, IP address is 150.200.4.107/24 and the network address is 150.200.4.0. For device 4, IP address is 192.168.64.90/24 and network address is 192.168.64.0. For device 5, IP address is 210.168.40.116/24 and network address is 210.168.40.0. And for device 6, IP address is 150.200.4.169/24 and network address is 150.200.4.0. And there must be an also public network for connecting all 3 LANs. Public network address is 64.210.130.0. On the screen you can see the visual topology that we made in the previous slides. It's important to get the topology of the related LAN and WAN networks like IP addresses, MAC addresses, device names. And it's also important to get service provider ISP connection informations like data speeds, consumer satisfaction ratings and SLA agreements, GDPR and ISP data retention agreements, and help desk services that's guarantees to provide to you. By taking this topology as an example, you can deduce the wide area network structure. Public IP addresses are assigned to your network router by your internet service provider ISP that used for accessing directly over the internet. As you see from the topology, ISP has its own network for connecting the routers. 64.210.130.0 is the public IP address of N1 local area network. 64.210.130.54 is the public IP address of N2 local area network. If you look carefully at the external IP addresses, you may notice that 64.210.130.0 will be the ISP network address. As can be understood from the topology, we can refer to the networks that configured by the ISPs as the router's network. The router network essentially has a local area network structure within itself. Within the ISP network, there are different security measures and different paid services offered to users. In this way, data communication takes place between routers and users like us at long distances can communicate with each other. Your connected device has a private IP or internal IP address that is assigned to your local area network. But when your device connects to the internet through your router, you have a connection through your router's public IP address or external IP address. And we know that private IP addresses are traceable by other devices on your local area network. Public IP addresses are traceable by other devices on the internet network. Let's talk about the private IP addresses of each LANs. Maybe you have noticed that the last octet of all the routers' private IP address is 1. This is not a rule, but in a large network, some rules need to be defined to identify certain devices. Here, the last octets of the internal IP addresses of the routers are used as 1. You can also use a different number for the last octets of the routers. When a new device will be added to a local area network, an IP address must be appropriate for the network address. Otherwise, the newly connected device cannot communicate with other devices. For N1 local area network, network address is 210.168.40.0. Device 1 server IP address is 210.168.40.16/24. Device 5 PC IP address is 210.168.40.116. And router internal IP address is 210.168.40.1. If you want to connect any other devices from other LANs like device 3 to N1 LAN, device 3 PC will not communicate other connected devices because device 3 IP address is 150.200.4.107 and network address is 150.200.4.0. But N1 network address is 210.168.40.0. They are different from each other. If your device which you connect to the internet while using it at work does not connect to the internet while using it at home, it may be that your computer's IP address continues to use the same IP address at work. Because the network address is different, the computer cannot access the internet while at home. But it could also be one of the sources of this connection problem.